welcome everybody to the meeting. It's been a long time that we have been doing X-ray astronomy. I know one of the first papers I worked on was the spectrum of Capella with Rolf Meeuwe, and this is just amazing how much more we know now with the XMM and how much we still have to learn from different objects that are further away. To understand them better, we need better data, and we look forward to Athena being launched, and hopefully it happens soon. So we start this meeting with Natalie giving an introduction, and after that we have some other speakers. So I'll give the talk to the microphone to Natalie. She'll take over. Thank you.
Yeah. Thank you ever so much for coming to the meeting. We've got a fantastic program lined up, so thank you to everyone for submitting some really exciting abstracts. Thanks as well to all of our invited and solicited speakers that we're going to hear over the next 3 days. So my name's Natalie Webb. You might see me quite a few times during this meeting, which is not necessarily planned, but yeah. I want to give you a short introduction to the meeting. And then obviously everyone else has got some fantastic presentations to show you. So there's a really, really busy slide. I'm sorry. I just wanted to give you some pointers for the week. First of all, obviously, I'd like to welcome you to Toulouse and also to this workshop. I've just, go through some of these points. They're quite important, actually. Please, I know you've signed in today, but you'll need to sign in every single day. It's a requirement. This institute has actually become under a restricted regime. So you're only allowed in this area of the institute. So not beyond those doors that are over there, and not up the stairs either, I'm afraid. I'm sorry, but you are allowed to go to the toilet, which are just here. So thank you. You're good. So yeah, you've probably found this room. So this is the meeting room, and next door there's some posters, and there'll also be coffee breaks, and lunch will be provided. We had hoped the weather was going to be nice. If it is nice, you can still eat outside. We've got some picnic tables outside for you. If not, I'm really sorry. It was nice weather before, not today. Yeah, it's all your fault. So yeah, practical things. So the lock, and I'm a member of the lock. You can identify us with a little red circle on the bottom of the badge. So they know what's going on. Everybody with one of those red circles know what's going on. If you need some help with anything, then just find one of those guys. Zoe actually knows everything. So this is Zoe in the door. So yeah, if you really need some help, okay, she's probably the best person to ask. So you've got hopefully a Wi-Fi connection if you need it. The EduRoam actually works the best. We've given you a connection to the other guys. Yeah, it's not always perfect. I'm sorry if there are any dropouts during your connection to that local Wi-Fi. If you could, it'd be the easiest thing to present via the central computer. So either upload your PDF or send it to us. If you'd rather present with your own computer, you're very welcome to connect to the Zoom with your Wi-Fi. As I say, if you've got the local Wi-Fi, you might find it might drop out, and I'm really very sorry for that if that occurs. So yeah, PDF ideally, but if that doesn't work, then feel free to connect with to the Zoom and then present via that. Yeah, I've already mentioned the posters and coffee. Yeah, so I've mentioned this restricted access is, yeah. I know lots of you have been to IRAP before, and you're used to just sort of wandering up down the corridor. You know, oh yeah, I know so-and-so's office is just here, it's just over there. It's actually quite serious. You could risk a huge amount of fine. I'm talking about hundreds of thousands of euros of fine, yeah, and prison if you do go into offices where you're not supposed to be in, I'm afraid. So yeah, just stay around this area, it's probably better. This is a hybrid meeting, as you probably know. So there's quite a few people connecting to the Zoom, so that everyone can actually hear really well. Ideally, please use the microphones if you're asking a question. So obviously, as usual, raise your hand and someone will come to you with a microphone so that everyone can hear. For all the remote participants, nice to have you with us as well. If you want to ask a question, please raise your hand on the Zoom or put something in the chat, especially if it's something urgent, like you can't hear a thing or something like that. Yeah, ideally, everyone will be respectful to everyone throughout the entire meeting. We've put a code of conduct on the website for the meeting. So it'd be nice if you'd have a quick look at that and make sure you adhere to those kind of rules. For all the speakers, your time slot actually includes 5 minutes for questions. Okay, so try and like table that in when you're sort of like giving a talk, that you've got a few minutes at the end so people can talk to you about your work. Obviously, that we've made quite long breaks and there's some discussion sessions as well, so there will be time for discussion at other moments. There's dinner organized on the Wednesday evening. It's not so far from here. It's a little bit complicated to get there. Sorry, I didn't think about that. I cycle usually and it's easy to go on the bike. But yeah, you'll need to have a ticket. We're going to distribute the tickets to those people that signed up to the meal. We'll distribute them tomorrow. We think there's some left over, so if you did want to sign up and you've not signed up, but we'll just check with everyone tomorrow about who's definitely coming to the meal. You'll need to pay at the restaurant though. It's 55 euros. However, lunches are provided for free every lunchtime. So yeah, I just want to say a few things about IREP, seeing as you're here, so you know something about the Institute. This is the Institute for Astrophysics and Planetary Sciences. It's quite a big institute. In fact, it's the largest astrophysics institute here in France. There's about 120 researchers working here. We have a lot of engineers. We've got a lot of development going on. I'll mention that in a few moments. And we have about 50 postdocs and about 50 PhDs, and quite often a number of interns and some contractual staff. We have 3 different sites. We have this site. We have another site just over there. Those people that went for lunch know where the other site is. And then we have another one in Tarbes because we actually run the Pic du Midi Observatory in the Pyrenees Mountains. We're also situated in a brilliant place for us. We're right next to the French Space Agency, which is just over there, and also the university, the Science University, which is just over there. So many people from the Institute are teaching up there. We work on all different kinds of things at this institute. I've just tried to give you a flavor. This is not, in fact, everything. So plasma physics, solar systems, sun, stars, interstellar medium, astrochemistry, compact objects, astroparticle physics, fundamental physics, galaxies, cosmology, signal processing. I suppose if you've got such a big institute, you will have a lot of subjects. And as I mentioned, we've got this really strong instrumental development that goes on here. I actually cited some high energy instruments that we've developed here or are developing here. So the SPI integral detector, the radiation monitors on XMM Newton. There's Eclair-Swarm that we'll hear about later on during this week, and also the XIFU for Athena, which again, we'll hear about that during the week. Another busy slide, sorry. So yeah, just a bit about Toulouse. I put a few things on the website to let you know about it. You probably know where we are because you managed to get here. So yeah, we're kind of down here somewhere. There's actually a lot of nice things to see. So if you've got a bit of time in the evening and want to have a walk around Toulouse, this is the central square, and it does actually look that nice. This is the main river, the Garonne River, that runs through Toulouse. It actually runs from the Pyrenees Mountains up to Bordeaux, where it goes out into the Atlantic. It's a nice place. Toulouse has actually existed for thousands of years. So we have very many old buildings that are actually quite nice. There's lots of these little tiny streets that are cobbled throughout the center of the town. We have some very nice churches, and this is the Saint-Sernin Basilica, which is apparently the largest remaining Romanesque structure in Europe. So if you want to go and see it, it's actually worth a visit. This is the Canal du Midi, which is a canal that to the Mediterranean. As a shortcut for delivering things, so you don't need to go all the way around Portugal and Spain. And it's actually very nice. You can walk down that canal if you want to, or cycle down it if you want to come here. It comes out just on the bridge, just by the bus stop. If you haven't had enough of space during this week, this is the Cité de l'Espace. It's a big science museum just on the outskirts of the town. It's worth a visit if you like anything spacey. We have the only life-size model of the XMM Newton Observatory, which is outside in these gardens. This is full-size Ariane 5. I think that might even be XMM, actually. I'm looking at it from here. Don't see very well from where I am. And if you want to go further afield, if you've got some time whilst you're here, I could really recommend Carcassonne. It's a fortified city, about 55 minutes from Toulouse, so around about here-ish. You can go down on the train. It's quite easy to get there and back. It's not too expensive. And also, we have the Pyrenees Mountains. On a nice day, you can see them from Toulouse, so keep an eye out when you look south. If you love skiing, you could go down there for the day as well. There's special tickets you can get on the train just to go down for the day. But yeah, it's some nice places to visit. So why Toulouse for this meeting? Well, first of all, this is the head of the XMM Newton Survey Science Centre. I don't know if you're familiar with the Survey Science Centre. If you're not, it's a consortium that was selected by ESA back in 1995. So it's been running for 29 years now. And it was selected to do a number of different things to allow the scientific community to be able to fully exploit the XMM Newton data. So you can see the 10 initial members of the consortium on this diagram. It was initially led by Mike Watson in Leicester until about 2012 or so. And then I've been running the consortium ever since. These are the different responsibilities that we were given. So we've developed a lot of the XMM SAS, so the Science Analysis System. So if you've ever reduced any XMM Newton data, you've probably used the SAS. So members of the people in the SSC, and many of them are here today, have developed a large part of that. We've also got our ESA colleagues with us here as well, and they've also developed a large part of the SAS. We did all the pipeline processing for the XMM Newton observations until about 2012. We had also, or we still do have a strong program to try and identify the serendipitously detected sources with XMM. So XMM being quite a large field of view, 30 arc minutes across, and also pretty sensitive, detects about 75 serendipitous sources per pointing. So obviously there's a target source and then all the other sources around. So we've spent quite a lot of time trying to identify many of these sources, and we'll hear about some of the things that have been going on, especially in machine learning during this week. And also we compile the serendipitous source catalog. So if you've ever used 3XMM, 4XMM, then this is where it's been made. So yeah, talking about the catalog. So this is the latest version of the catalog that we released. This is 4XMM DR13. It came out in June 2023. We release a new version of the catalog every year. And this is the 4XMM version because it was the full 3 reduction of all of the data with the latest software and the latest calibration at the time of that re-reduction. And DR13 because it's the data release 13. So we're not quite at 1 million detections, but we are actually at 1 million detections thanks to the STANKS catalog, and I'll come on to that in a few seconds. But we're about 656,000 unique sources. So yeah, we have now been beaten by eRosita on the unique sources front. We have about 36% of our sources that have got spectra and light curves that are ready-made, ready to be used. You'll hear more about some of those later on during the week. We've got about 91,000 extended sources, and it's kind of an interesting catalog because XMM has been flying for 24 years now. That there is a very long time series. Some of those sources have been pointed about 90 times. So you can actually follow your source over 24 years with interesting resolution. So this is just the distribution of all the pointings for XMM over the last 20 odd years in the Hammer 8 off, so the center of the galaxy, and this is the plane of the galaxy, the blue points of the DR12, and if you're good enough eyesight, you should be able to pick out some of these red points, which is the addition for DR13. So I mentioned the stacked catalog, and this is something we've been doing for the last few years, and thanks to a lot of work by Iris Trauson, and I definitely saw it that she's over there. Excellent. So yeah, a lot of the fields have been pointed many times, as I mentioned. And so if you take all of those pointing and stack them together, then you're obviously going to reach much deeper fluxes, but also you're going to have much better statistics, many more photons. And so adding them up is useful. I'm sorry, the video projector is not good and there's a lot of light in here. So this is just a single observation, for instance, of one particular field. And then if we take 31 observations of that and stack them together, you can immediately, I hope, with this kind of video projector, see that there's many sources in the field of view. If you don't see very well, then that's the single observation with a source detection run on it. And once you've stacked it up, you can see we're detecting many more sources because we're able to go to these deeper fluxes. So that's the SSC work, but the main reason why we've put together this workshop is because we've been running a project since April 2021. It's a project that runs over 3.5 years, and it's called XMM to Athena. You're probably familiar both with XMM that I've just mentioned, but also Athena that should hopefully be launched from 2037. If you want more information about the project, you can just follow this link. But the whole idea behind this project is that because XMM has been flying for so long, people are using data in a different way now to the way that they were doing that like 20, 25 years ago. And so we needed more development to keep up with the way things are being done. So originally, I think people were more looking at individual sources, but nowadays work is focused much more on populations of sources. XMM was never a single wavelength. It's always observed in the X-ray or the UV and the optical sky. But people are much more into using the multi-wavelength and multi-messenger information for every single source today. And so we need more software and technology to use that intelligently. Also, we're moving into the era of time domain astronomy. We saw that with a number of different events, but probably GW 1708-17 was one of the big events where time domain astronomy touched a lot of people. So it kind of requires doing things differently. So what we've done in the framework of this project is we've taken scientists from the XMM Newton Survey Science Center, but also from the Athena Science Ground segment, and also from other members of the X-ray community, and put all of that know-how together to try and make some development to sort of take into account all of these things. And also, we can develop new software and methods to accompany this emerging astronomy, but what we want to do is then use it in the future for Athena. So what we're putting together now is being tested on the XMM Newton data, but then we can go further forward and use it with Athena. So yeah, the consortium looks quite similar to the SSC map, but not quite the same. So we have our colleagues down in Athens, for instance, and again, many of them are here in the room with us. And so yeah, the idea that we've put together is that we've got some new classification software that you're going to hear about for statistically identifying all of the XMM sources, both in the X-ray, but also in the optical. We've improved the software for stacking all of the data to be able to reach even deeper fluxes than those we were reaching before. We have machine learning algorithms to determine the photometric redshifts. That means you can get a photometric redshift for every one of your extragalactic sources, which is very useful. And we're also using that as well to try and get very good spectral modeling of our sources. So we've put together also software to detect very short-term and also long-term variability. Again, we'll hear about all of these things during the week. To make alerts for XMM Newton. We've made an improved sensitivity estimator, and you'll hear about that later. But also above and beyond that, we've made a lot of new outreach material that you can use if you do any outreach activities with X-rays, or in fact, not even X-rays. And we'll talk about that towards the end of the week. And we're also hopefully training the next generation of X-ray astronomers that will be there to use Athena when it gets launched. And so, yeah, they've got all this know-how. So just a bit of advertising. The whole idea of a lot of this is to put all of that know-how into the next version of the XMM Newton catalog. And that's going to be called 5XMM. And we plan to re-reduce all of the X-ray data with XMM, all of the data with from XMM in just a few months, actually, from now. And that will be, again, with the best calibration and the best software that we have available. And we're going to be producing a single catalog. Until now, I just showed you the detection catalog and the stacked catalog, but it'll be a single catalog now, and it will contain all of the single detections, but also all the stacked detections, stacked sources. We'll also be providing you with upper limits. They're available in the stack catalog, but again, that doesn't cover the whole of the data that's available. We'll also be including identifications of all of the XMM mutant X-ray sources and identifications for the UV and the optical sources detected with the OM. So again, you'll be able to tell whether you're looking at an AGN, or maybe if it's a star, or maybe if it's an X-ray binary, or other things. We're also going to include multi-wavelength and multi-messenger counterparts, photometric redshifts that I mentioned earlier, the fits to the spectra, but not only the spectra we produce, but also fits to the 5 bands that you're probably used to seeing if you use the XMM catalog. And then physically motivated fits with the type, using the type of the source and the photometric redshift, etc., for the best spectra. And also information about the short-term and the long-term variability. So that sounds like a massive catalog. We're doing everything we can to make it small enough and manageable for everybody, that you're not suddenly going to have to download thousands and thousands of columns. That's not the plan. But yeah, it should be quite a complete catalog, and that will be coming out in 2025, so next year. So yeah, the scope of this meeting. First of all, to discuss data. Many of you intensively used large volumes of data. So discuss things like the format and the accessibility of not only X-ray data, but multi-wavelength and also multi-messenger data. Understand the uses of the catalogs, because that's really important. We held a meeting back here in 2018, and that's where we got a lot of the ideas that came from, like, how people want to use the catalogs if that information's not available. So we want to talk about that now and see what we can add in maybe in the future for new catalogs. I think, as I say, we're moving towards time domain astronomy. There's going to be LSST that starts taking data in less than a year, for instance, and there's a number of other time domain observatories. We have Rosita that we're going to hear from later as well. And then obviously investigating new source classification and machine learning techniques. So I mentioned we've made some developments, but I know you've also done a lot of work about inventing new kinds of methods for identifying and classifying sources. Also want to tell you about the new software, the new methods that we've developed, and hear about yours as well. Want to discuss upcoming missions. There's a number of new missions, but also upcoming software and upcoming tools that maybe are not out there now, but people might want to know about. And also, we'll take a few minutes to reflect on the importance of outreach and diversity. I think the main aim of this is to provide better catalogs and software in the future. And yeah, with all of your input, I'm sure we can do something excellent. So XMM to Athena project will hopefully allow to exploit all of the XMM mutant data in the best way possible. We're providing new functionality and much more complete catalogs. We've got this new version of the sensitivity estimator that I'll show later on. We've got catalogs of spectral fits. They're already out. You can download them from our XMM to Athena webpage if you want. There's also catalogs of classifications and other things on there. We have DR14, the next version of the 4XMM catalog, is actually in production and should hopefully be done in the next couple of months and be out for your use. And as I mentioned, 5XMMs for next year, probably, yeah, mid 2025. The project has been preparing new X-ray community for Athena when it gets launched, and also trying to make astronomy as accessible to the public as possible. And yeah, knowledge of XMM mutant and X-ray observatories in general is just being passed on to the new generation. So So let's, look forward to a productive meeting. I look forward to hearing all of the different talks that you've got to give. And thank you very much.
Well, thank you, Natalie. It was a very nice introduction to everything. I wonder if there are questions.
Quick question. You mentioned Rosetta. Is there going to be some discussion about cross matches with XMM catalog sources and where there's a match, where there's not a match, etc., etc.?
I'm not sure if there's actually going to be a discussion about that now. There is definitely going to be that work that's going to be done. I don't know if you're going to talk about.
I'm not going to talk about that. Maybe Mara and her talk about multi-wavelength. Oh, sorry. Well, I'm not going to talk about that today. Maybe Mara the other day.
So I'm definitely speaking about the cross match of X-ray and multi-wavelengths, and we are providing to the community the catalog, so everybody is welcome to do the match. For sure, from Rosetta side, we are using XMM as a reference for variability, light curves, and so on. But we do not, on our side, we are not having planned a catalog that match XMM and Rosetta. It is definitely something that the community could come up with.
Erwan might have a few words to say about that at some point as well. I don't know if you're going to talk about it in your talk, mention it. Yeah, okay. So yeah, there will be something later on this week.
Anybody else in the room here? Somebody online? No? Okay. Well, thank you, Natalie. That was very much in time.